Great. So I'm David Stevenson. Who the heck is that? I'm a guy from Pivotal Labs. I know Jonathan Siegel and I used to work together down in Santa Barbara, and so I'm here. I've given this talk several times, but I'm getting much better at it each time. I'm going to focus a little bit on scalability because my understanding is that you've been getting a lot of talks on performance, and you're probably getting a little bit bored about performance and scalability, although I think we'll probably all agree they're linked. So I'm going to try to focus on the scalability side of things, and also because I'm from Pivotal, we're pretty extreme about our Agile process, and I'm going to talk to you about how does that fit in. Like how do you do performance optimization, and how do you do scalability while trying to be Agile, at least as Agile as possible. So I'll give you my take on that, and then maybe we can start a discussion. Cool. So there's a lot of approaches to optimization, and I think like traditionally engineers, computer scientists, capital A architects, we enjoy like performance optimization. It's really fun. So like we like to do it a lot and as early as possible. That's not where I like to be, but I like to be kind of here closer more on the like let's optimize as late as possible. And maybe like there's an extreme approach to Agile where you really are on the far end of this spectrum. Like this is proactive optimization, and then there's reactive optimization. I like to be mostly reactive because I think I find that a lot of people spend a huge amount of time optimizing problems that they don't have. They like to focus on optimization because it's fun and because we're computer scientists. We enjoy solving these hard problems. But it is not necessarily good for the customer, and it's not good for our business. Before I worked at Pivotal, I was at a startup that actually went under. And during that time, we spent a lot of time on optimization. Like I think we spent 2 months rewriting the core of our application. We ripped out all of the Ruby logic and replaced it with stored procedures. And that was about the time we started having to lay people off. So I've always seen this correlation in my mind between like spending massive amounts of time on optimization and running out of money. And I think those are often related. So I like to be as reactive as possible without being so naive that I'm obviously making a mistake. And I know that's a little fuzzy, but maybe we'll look at some examples and try to figure out exactly what that means. So the process that I use for optimizing is similar to the process I use for writing software. And it's like I build some things, and then I measure them, and then I optimize them. And maybe I don't even optimize them. I only optimize them if there's a problem. In the same way, I only refactor my code if it needs refactoring. I don't optimize preemptively, and because I've sort of built some stuff and then measured it, I know whether I need to optimize it. And I'm not doing it in advance. And there are a lot of downsides to optimizing early, and I don't think I have to sell you on that, but beautiful code is usually not performant. That's the problem. So when you decide to optimize, and you end up with this code that is much harder to write, and it's much harder to read, which has obvious downsides to everybody on your team. If I come into an application that has been heavily optimized, it's really hard to understand the business rules. The business rules have usually been abstracted or been pushed aside in exchange for these optimizations, which really is bad for a couple of reasons. Like obviously it's hard to learn code that's not beautiful and not easy to read. And it's hard to change anything at that point. Like if you optimize, like when we converted, say, our Ruby logic to stored procedures, changing those stored procedures was not a lot of fun, and we ran out of business before we actually had a chance to change them, but I imagine that changing them was going to be a lot harder than anything else. So you can get yourself into trouble if you optimize early. I like to think about it as a plan, like for scalability especially. Like I have a plan to scale every component of my application, but I'm not going to execute that plan right away. And really, I oftentimes never execute the plan. I have all these grand plans for scaling, and they're a lot of fun to come up with. But that's as far as I usually go, because most of the time, we don't need to execute that plan. And sort of like the best plan is a plan that you didn't have to execute, because you didn't waste any time doing it. I sort of have a great job at Pivotal, though, because I get to do a lot of performance optimization. I kind of go around from client to client doing these really hard scalability and performance problems. So I kind of get to like optimize all the time. But when I come in, I know it's because people are needing the optimization because they're actually having problems, as opposed to speculatively, I'm a CEO, so there's probably going to be like millions of people using my site. Even though I don't have any users, there's probably going to be like millions of people. So you guys should worry about performance. That's not the circumstance I find myself in. And I think there's sort of like, people get really worried that it's going to be too late. They're like, well, if I don't do it now, what happens when some really big event happens? And I have a couple things to say about that. And I know this is wordy and my talk's a little wordy, but At Pivotal, the product manager, they dictate the backlog, and they know what's going to happen most of the time. Like, they're knowing about big demos and press coverage and such, and they know maybe approximately how many people are going to hit the site. So if that's a requirement, obviously don't be naive. Don't not scale and don't not optimize until it becomes a problem. If you know you're going to have X number of people, like if you know that your product is going to be announced on Oprah's show, you should probably do some work in advance. You should say, well, how many people are going to be watching Oprah, and what percentage of them are going to hit my site? Okay, well, now I can write a test. I can write a load test. I can verify that my site performs. And so the product manager is going to kind of be aware of that. And I think most of you probably know where your site is going to become viral. So the other possibility, right, is that maybe the site explodes unintentionally or in a way you don't understand was going to happen. It wasn't because of press coverage. It's because you told him, you told that other guy, and now a bunch of people are using my site. Well, I think most of you know if your site's going to become viral, like what part of the site, like where your loops are within the site. So all you have to do is optimize those loops a little bit and think about maybe benchmarking those loops and say, well, could we handle like 10 times as many people as we're here right now? Well, that seems pretty good. If even twice as many people are as here right now is probably not going to happen overnight. And so, because we're measuring these things, we kind of know about like what we can handle and what we can't handle. So there's no surprises. And again, like the test suite thing, right? So on Pivot, so we write tests. The test suites allow us to actually change implementation. We can just throw out like an implementation and rewrite a new implementation. And it's great because we guarantee that the new implementation does what the old implementation does. So it kind of removes a lot of the barriers to optimizing that usually people say, well, if I optimize, I might break it. So we're going to have to like do extensive QA after I do optimization. And the answer to that is no, you don't. You just have to have tests that verify your application is working. And then you can throw out the whole application and write another one. And you won't have to spend a lot of time verifying that it works. So talking about scalability, man, like scalability falls into several categories, right? Your application, every component in your application scales in one way or another. Like linear scaling is my favorite because it means that if I add more hardware, I'm going to get more throughput or more performance through my application. So there's other scalability plans that are a little bit more suboptimal, right? Logarithmic is interesting. Diminishing returns. The more hardware I add, it will give me a little bit more performance, but then I add even more hardware and maybe a little bit less, and you start diminishing returns. These are kind of dangerous scenarios to follow yourself into. And sort of like the worst, right, is the flat line. Like, this is it. If I add more hardware, we cannot get any more performance or any more throughput out of this application component. So you want to know, for every component in your application, like, what's your scalability plan? Like, do you expect it to scale linearly? Do you expect it to scale not at all? And you don't really want to be in this final category. We have no idea like how this component is going to scale. We found ourselves in this situation with like an eJabber-D that we didn't understand, that we were brought into a project that was running eJabber-D, and none of us really knew how this was supposed to work. And so we got in trouble because we didn't really understand the scaling plan for eJabber-D, and we didn't know like could we add more hardware or whatnot. And so you don't want to find yourself in this scenario. For every piece of technology that's in your site, you want to know what your scaling plan is. So great. So that's some of the philosophical, like, when do we measure? When and why do we optimize? Measuring is really important, right? If our application is going to scale and it's going to be performant and it's going to handle load, like, we've got to know how much load we can handle, and I don't know, when scaling or performance, whichever one you're most interested in, becomes a problem. And I guess we should disambiguate, right? Okay, so performance is speed and scaling is capacity. And they're related because if I make a site that's faster, it can obviously handle more traffic with the same hardware, almost always, right? If I can decrease my request time from 100 milliseconds to 10 milliseconds, I can usually handle 10 times as many requests. But most of the time, scalability is achieved by linear methods, by adding more hardware. So we add more Rails application servers, we add more load balancers, stuff like that. So I just wanted to clear up the relationship between those two things. So assuming that we want to be able to handle load, and we kind of have some idea for the load we'd like to handle, but we don't want to spend time optimizing unless we need to, then measuring becomes really important. We've got to know when there's a problem, and then we know whether we should spend time fixing it or not. So like the simplest form of this is just go into your production application, which is already running, and make sure you're running some things, right? Newrelic gave a talk here. Make sure you're running things like that. We sometimes use really simple things like CloudWatch is actually not terrible at just monitoring like CPU utilization, for example, and look at your application and say, how loaded down are we right now? And how loaded down have we been recently? If all my machines are spinning at 10% CPU, I'm probably doing okay. Maybe I got a lot of excess capacity. So that's the simplest form of monitoring that you'll probably want to have all the time. And so then you say, okay, well, I've got monitoring, and I think my application can handle some load, but I kind of know that it needs to handle a certain amount of load because maybe we have a big demo coming up, or we have some press release, and I expect some traffic. So oftentimes, measuring includes load testing. And sometimes you need to design a load test, and other times you can just use production data as your load test, or use production traffic. Some people just want to know that they can handle the traffic they have right now, or maybe twice as much traffic as they have right now, and feel good. Other people know they're going to get 10,000 people coming in over the course of an hour because of a huge event. So sometimes you have to design a load test, and sometimes you're lucky enough to actually just use existing data for load testing. I know that some people like replay traffic, and there's all these crazy techniques where you're like split traffic and double it to see what it would look like, or split traffic and replay it. However you want to do it, that's one way of generating a load test, right? You could use existing production data and like replay it at a higher rate or something like that. I kind of like, if I'm going to design a load test, I kind of want it to be like an RSpec test, actually. I want it to be like, given some very fixed scenario, some very deterministic set of data, and some very deterministic set of traffic, like how would the site perform? Would we be able to handle 10,000 of these users, or 20,000 of these users, or just 100 of these users? So in order for that to happen, you need a data set, right? And you need load. And so, generating a data set is basically a huge pain. And some people like to just use production data for their data set, which is awesome, because it's really easy. You already have production data. You just use that. It's non-deterministic a little bit, because your production data changes over time. But it's also a lot of work to do the opposite, right? It's a lot of work to generate a load test and actually generate a data set. I've done this several times before, where we'll basically define a seed file of load 500 users into the database and load all their data. And oftentimes we use Factory Girl for this, because we probably already have it in our test suite anyway, so we know how to make any object in the system. We just make a bunch of objects, put them in the database, and then we generate some load. This is acceptable, but I kind of like using production data more, just because it's less work. But this active record importer gem is awesome for this, by the way, because it allows you to do bulk insert statements, right? Rails won't let you do bulk insert statements, so basically inserting 10,000 rows takes a really long time. And this solves that. And then you've got to decide what tool you're going to use to generate your load. There's some great tools out there. These are not them. Apache Benchmark is really crappy, but I think you probably used it maybe once or twice in the command line. You're like, how would my site perform if I had 10 threads hitting this one URL? It's a terrible idea, because your users aren't going to sit one behind the other 10 at a time. So HEB perf is sort of the Rails standard for a really long time. It's got the advantage of you basically set the traffic rate. You say, how many people per second are going to hit my homepage? And HEB perf will just launch a thread every X number of milliseconds hitting the homepage. And what happens is, when you're doing badly, those threads start to pile up, and you have you run out of file descriptors. And that's a bad sign. That means that you're putting way too much load on your machine and you can't handle it. So HEB perf was sort of the gold standard. It's really hard to use, and it only does one cookie. So if your session cookie is longer than 255 bytes, it gets cut off. Or you set 2 cookies, only one of them gets carried from page to page. So it's not easy to use at all, and it's very limited. I've had a lot of people talk to me about this next one, JMeter. It's a graphical, it's a Java-based benchmarking tool. It's much more powerful than either of these other tools, and it's graphical. It can be scripted, which is pretty cool. And my understanding is, I've only used it once or twice, but my understanding it's a pretty good way of generating load. It doesn't really simulate a real browser, right? None of these things simulate real browsers. You're basically saying, hit this URL, and then hit this URL. But when you're hitting that URL, you're just making a GET request. It's not a browser. It doesn't download any assets. It doesn't carry cookies, although JMeter might carry cookies in a session. So like, what I think is awesome is Browser Mob, which is this tool that lets you launch browsers in the cloud. And it also runs basically HTTP perf. So if you just wanted to run a non-command, like a non-graphical browser, it costs 10 times less, and you can launch non-graphical browsers. Or maybe it's 50 times less. You can basically launch a lot of HTTP perfs for the price of one Selenium-driven browser. But either way, you write your load tests in JavaScript, which is awesome. So you're saying, like, get this page, and then click this link, and type in this form field, and hit enter or whatever. You can see from this graph, this is an example of a browser mob test that we ran. As we scale up the number of transactions happening, at some point this brown line is failures, and the site's humming along pretty well, and then we start to get a lot of failures. And at some point, like, so many things are failing that like it can't actually add any new traffic before the script fails and has to be restarted. So you can see some nice scaling, like when things really started to go downhill, and then when things really, really started to go downhill, and then other stuff out there when the data became unreliable at that point because the system was so loaded down. So this is a great tool. It's a little bit expensive. I think we've seen people run tests that cost thousands of dollars on this. If you want 1,000 browsers, it's going to cost you a lot of money. But try starting 1,000 browsers. It's not easy. Cool. So now we've decided. We've written some code. We've measured the performance, and we've decided to optimize. And so I'm assuming that we're all here because it's a good idea to optimize, and we've verified that it's necessary to optimize, and we're not making that decision in advance. So how do we fix these various issues? Like, how do we optimize our scaling and performance plans? And I'll talk about that for a little bit. Just make sure I'm not running out of time or anything crazy like that. Cool. Excellent. So first thing you should do is put your site behind a CDN. You're basically crazy to not put your site behind a CDN ever since CloudFront started doing proxying. You can just put your site behind CloudFront, and CloudFront will proxy every request to your application server through it. And if you send cache headers that say cache this page for 5 minutes, CloudFront will not ask you for 5 minutes for that page. And always page caching is better than fragment caching, but people are nervous about doing page caching, and they should be, because it's hard to make a site that really feels dynamic if everyone's seeing the same version of the page. But it can be done, right? I mean, we just use cookies, and we use JavaScript, and we render everybody the same page, and we start showing and hiding things that are interesting. So we can't cache everything, but we can cache a lot of pages. Some of our biggest traffic pages should probably be cached. Like, if your homepage is not cacheable, that's probably a bad sign. Like, your homepage should probably be cacheable, even if it's like only cacheable for 1 minute. Maybe you have some statistic on your homepage that you want to change. It's probably okay if people see the same page for 1 minute. I mean, Akamai or CloudFront will only request that page once a minute, so that's massive. You could be getting thousands of hits, and you're only rendering once. Caching obviously has problems, right? Sweeping is difficult. If you want to make a really dynamic site, when somebody changes something on one page, it expires that everywhere. You're likely to potentially make mistakes, and you could use TTLs on that, but then if I display the same piece of information on several pages, they'll expire at different times, so users will see different things. So it kind of makes like a weird experience if you have TTLs going on. And what happens when you deploy code? I think there was some rumor at Facebook that if they ever lost all their Memcache servers, they would be unable to recover because their site was slow enough that they could not rebuild it all. So how do you deal with deployment? Do you expire the entire cache? Or do you let people see old versions of the site and new versions of the site at the same time, depending on which page you're on? So caching is easy in a lot of ways, and it keeps your code looking really clean, but it has some major downsides. I mean, you're always going to have to eat that cost once. And if I have 1,000 or 1,000,000 pieces of content that are popular on my site, caching is really not feasible, because I can't cache 1,000,000 pages. I have to get 1,000,000 hits anyway, at least once, to generate each of those pages. So optimizing becomes a much better solution. The biggest way that I optimize is garbage collection. That's the first thing I do when I come into a project. If you're not using Ruby 1.8.7 Enterprise Edition with the right garbage collector variables, you're throwing away at least 50% of your time in terms of optimization, because this, my test suite goes 50% faster. The Rails environment loads 50% faster. Ruby 1.9.2, I guess you can use it, but it has to be really, really new version of it. I'm not even sure any of the released versions of 1.9.2 support these environment variables yet. But if you don't know what I'm talking about, look at the Ruby Enterprise documentation and look at the Twitter GC settings. That's the one I always use, and I find it, in my benchmarks, it's unbelievably different. The other thing that I sometimes use is perftools.rb. This is cool. This is before we installed Ruby Enterprise Edition 187. We were spending 44% of our page time on garbage collection. So it gives you a great little graph of what's going on. We also noticed that we were spending 11% of our time doing active record base inspect. So this caught a bug in some plugin called declarative authorization that we never would have found because we just couldn't figure out where all the time was going. But that big box told us exactly what we needed to know, and we ripped out that implementation, and everything was fine again. So again, a word on scalability. Most parts of your application are going to scale linearly. Your load balancers scale linearly. Just add more load balancers, use round-robin DNS. App servers, more or less in Rails, scale linearly. We can probably add 100 app servers before this becomes a problem. Key value stores like memcache, they scale linearly too. Memcache just hashes the keys, right, and to figure out which server to talk to. So you can have 10 servers and you get 10 times the throughput. That being said, right, you could have a lot of traffic to one single memcache node if you have a really hot piece of content. So it doesn't necessarily scale linearly, but it's somewhere between linearly and logarithmic. Document stores are sort of the same way, like Mongo. Mongo knows exactly which server it should talk to get any piece of content when you do a sharded database. Now, your actual relational databases are the biggest bottleneck, so you should be thinking about optimizing your database access, which is probably not news to any of you. But you want fewer queries and you want faster queries. And eventually, you don't want a database, but I hesitate to suggest that solution to anyone, even though it's really awesome to not have a database. Databases are really good at doing a whole bunch of stuff, so I hate to rip out a database and replace it with something else. So all the standard things for optimizing database access. Look for look for things in where clauses and group bys and order bys. Make sure you have indexes on all those. Make sure you have multi-column indexes. If I have this query at the bottom here, make sure I have an index that spans those columns in the right order. And the order is always fun, and you can look up multi-column indexes in MySQL and such. Range queries are bad generally, like these two range queries where the latitude and the longitude are being checked. MySQL can't do nested range queries, basically. It has to do something called an index merge. So you got to watch out a little bit for range queries. You can do one range query easily, but when you nest them, you end up with doing some crazy merging on your indexes. Temporary tables are obviously bad. I think people know that, but they're created implicitly all the time. So you're going to want to use tools to figure out how your database access is going. You're going to want to use explain, right, which is the MySQL command to analyze a query. There's a whole bunch of these tools out there. Rackbug is really cool in that it gives you a little bar on the top of your site to analyze your database usage. Query Viewer is the same thing, just gives you a list of all the queries on the page and which ones did temporary tables and stuff like that. Newrelic will do this in developer mode, which is kind of awesome. And the slow query log, also a pretty good source for figuring out which things are going really slow. So Newrelic, as I was mentioning earlier, Newrelic's a great tool, but for example, right here in this trace, it has no idea what happened between user.find and avatar.find. It's I have no idea where all this time went. And this is because Newrelic doesn't instrument everything. This is where perftools comes into play, right? You install perftools and you find out exactly what happened between those two times. But it's very expensive and you don't run it on production, whereas Newrelic you run on production. So it's a good tool, but there are limitations if you don't instrument everything. And if you're talking to some service that Newrelic doesn't instrument, and you want to know how much time you're spending talking to that service, it's pretty easy to instrument it. They just don't instrument everything by default because they have no idea what you're going to talk to. Another great thing to do is prefetching data, right? So we obviously want to make as few queries as possible. We don't want to bring back 100 rows and then execute one query for every one of those rows. We want to bring back 100 rows and all the data required in a second select or a third select, or maybe a single select. Rails lets you decide when you have an association. Like if I want to bring my friends and their friends, I can do this with includes, or I can do this with eager load. It sort of depends on if I want one giant select statement or 3 simple select statements. You almost always want the first one. Denormalizing your data is also kind of an awesome solution. Counter caches are a really common thing in Rails. You do have to be a little bit careful about deadlocks, and I'll discuss that in just a second. But Denormalization is the enemy of, you're repeating yourself, so it sounds like a bad idea, but sometimes you really need a piece of data a lot closer to you, even if it means I'm duplicating that information. Or like maybe I have a product catalog, and I want to have a whole bunch of information about a product that actually comes from like 10 different tables, but I put it in Solr. If I put all those fields in Solr that I care about, I can execute one Solr query to bring back all the data that I need to render a product catalog. And you can do searching on it at the same time because it's Solr. So I use Solr as like a materialized view, which MySQL doesn't have materialized views, so I use Solr for that. Unbounded data is terrible, so this is something I saw on the startup company that I was at before Pivotal. We had some code that when a certain event happened, it iterated in real time over potentially an unbounded number of things and then called some method on it. And this brought down a production database for like 15 minutes until we could figure out what was going on. What had happened, if you look at this code, is that once the fifth vote was reached, there were thousands of actions, and like the person who cast that fifth vote was sitting there waiting while the system was iterating through all these actions and adding points. We replaced this with a stored procedure, so you can see how far that got us. But the last thing about databases is write issues. You may not be realizing you're causing locks, but you're causing locks all the time. When I open a transaction and I go, update some row, maybe I change the state of my order to like paid or something like that, and then I go talk to my payment gateway for 5 minutes, that row is locked for 5 minutes until the transaction is committed. So nobody else can lock that row, which is fine if it's my order. But let's say I have an inventory count for some product. I don't want to be updating the inventory count for that product and then going and talking to a payment gateway for even 3 seconds, because that means nobody else can buy that product for 3 seconds. So you end up like, with some hot product, you might end up with 10 or 15 threads waiting in line for me to give up my lock so that they can go lock it for 3 seconds each. And that's how you fill up all your database connections and your site grinds to a halt. You can also explicitly lock things with select for update, but most people realize they're locking rows when they do that. So the key really is like use after commit or do something, send your emails outside of transactions. Anything that could take a long time, keep that out of the transaction because you're locking rows. You're almost definitely locking rows. Unless you're doing straight insert statements, you're locking rows inside of transactions. And the last thing that can happen is you can get deadlocks. Most of the time, these are really hard to figure out what's going on, but it's almost always that like people are grabbing rows and they're grabbing multiple rows in different orders. So if I like lock my user and then your user and you lock your user and then my user, and we both try to do it at the same time, we'll each get the first user and not the second. So if let's say I need to actually lock 5 different records, I often sort them by ID and then lock them that way so that at least like there's some deterministic order. If we all try to lock the same records, one of us will get the first one and then nobody else can continue until, you can imagine scenarios where there's multi-way deadlock still. DHH had this deadlock retry plugin for Rails a long time ago. I guess it's an okay idea to retry a transaction if it deadlocks because maybe this time I will be able to get those rows. I'm not sure that's a really good idea because I think that might end up involving you going to your payment gateway multiple times, which could be really bad. It sort of depends on what's in the transaction. And maybe the last technique that we sometimes find ourselves using at Pivotal is like, and this is the hot shit, right? Everybody wants to render their views in JavaScript. Like, we'll send down JSON and we'll just render our views in JavaScript and we'll render like this really simple static page. Then the static page will maybe make some requests to get some JSON and then render the view, which is really cool. I think it's a little bit, it's a lot of work, right? It's a lot of work to do this, and it's kind of hard to test. But with like Jasmine or any of the JavaScript testing frameworks, you can actually build a pretty good site, mostly in JavaScript. Twitter's built their new site entirely in JavaScript. Facebook is basically a giant JavaScript app. So this obviously can be done. It's just harder, and I think you don't want to go this route until you have enough load to justify this route. Most of the time you can render these views server-side and everything's fine. Okay, that was pretty fast, but I think I'm about done. I've got a couple minutes for question and answers. Does anybody have anything they want to bring up? So the question is, how do you deal with asynchronous processes? I'm sort of interpreting that as when. I would not do it right away. Like, I always write something synchronously before I write it asynchronously because it's so much easier, right? And it's really easy to later, you put your logic in a method, and you can synchronously call that method, or later you can make it asynchronous with rescue or any of these queuing systems. So I would say, why build something asynchronously when you could build it synchronously? I guess the caveat to that, like, don't be naive. What if it did an unbounded number of actions? Like, sending an email maybe isn't really unbounded. But if it did like an unbounded number of things, potentially, that would be a good time to make it asynchronous from the get-go. Yeah, so just to repeat for the camera, yeah, I think you're completely right. You're saying that JavaScript is a very scalable platform because you get to harness all these people's browsers. We had this conversation just today on a project. We had like a bunch of Facebook users potentially are visiting a site, and we need to get their social graphs and pass it through to another third party. And we said, well, we could do that on the back end, or we could make their browsers all download their own social graphs and send it to a third party without us. So that way we don't have to worry about any of this stuff. So it never hits our site. So yeah, there are plenty of cases when you want to leverage people's browsers as a giant compute farm. And Ajax makes that all possible. Or JSONP if it's cross-domain, stuff like that. Okay, thank you very much.